So I'm going to give a short reminder on sequence and series. First of all is AP. The general formula is Tn equals to A plus n minus 1d. I'm sure you know what Tn, A, D, and n are, so I'm not going to mention much about that. There is one thing you have to remember though. N is an element of natural numbers. Natural numbers is 1, 2, 3, 3, and so on. Some might argue it starts with 0, but the main thing is in this book, in the UEC book, is that it starts with 1. So that means that it has to be a positive integer. Positive integer, that means it cannot be a fraction, it cannot be negative. If you get a negative number, it is invalid. If you get a decimal number, it is invalid, unless we're talking about this thing here. We're solving about finding the first term that is more than a value or less than a value. For example, find the first term that exceeds the a 0. Find the first term that exceeds 9,000. Find the first term that is lower than 5. Then we will try and solve it. What we will get in the end is n is going to be a fraction. So n is going to be a fraction. So when n is going to be a fraction, when n is a fraction, we cannot let n directly be the answer. Like for example, if we get n equals to 8.89, we cannot let 8.89 be the answer, because remember, we're talking about natural numbers here. So we want to try and find the closest whole number that fits the thing. So if you have 8.89 and you know that n, if n, if let's say we get n is equals to 8.89 kan, not 8.89, yeah, 8.89. We get n is less than 8.89. So 8.89 is between 8 and 9. So we want to, since n is less than 8.89, we have to use 8, even though it's closer to 9. So yeah, I believe these ones are slightly mistaken, so don't look there. Just look at what I wrote. So if you get n is less than 8.89, for example, then n has to be less than 8, because 8 is the first whole number that fits this thing. Not n is less than 8. N is equal to 8, because 8 is the highest number that fits this thing. If you get n is more than 8.89, then n equals to 9, because 9 is the first number that fits this thing. So that's one thing to keep in mind. Another thing that is generally mentioned is the arithmetic mean, which is basically the average between two arithmetic values. So the arithmetic mean here is y equals to x plus z over 2, where x, y, and z are in AP. Y equals to x plus z over 2. Y has to be the middle term in this case. So the thing that confuses me back then is you can insert multiple arithmetic means. So if you have multiple arithmetic means can be inserted, for example, in A and E, you have to insert 3 arithmetic means. So you let them be A, B, C, D, E. Note that A and E are going to be given as actual numbers in the exam. So it will give you, like, for example, 1 and 9. Insert 3 arithmetic means between 1 and 9, for example. So yeah. So if you have 1 and 9, then it's 1, 8, 1, B, C, D, 9. Then you have 2 ways to solve this. Most people will use this one. So E is the 5th term in this AP. So T5 is equal to E. Then we use the A plus n minus 1d formula. So I'm going to use this. So E is 9. So 9 equals to 1 plus 4d. Then D equals to 2. So hence we get B equals to 1 plus 2, 3. C is equal to 3 plus 2, 5. And 5, 7, and then 9. But the way that people want us to use is this one, where you use arithmetic means and then find the arithmetic means of those means. So for example here, C is in the middle, so C is equal to A plus E over 2. So 9 plus 1 over 2 equal to 5. B is equal to A plus C over 2. So 1 plus 5 over 2, that's equal to 3. D is equal to 7. So both of these work. And then lastly, you have to be aware of both. Sn is equal to n over 2, a plus l. L is Tn, the final term. And if you let Tn equals to a plus n minus 1d, then you will get this. 2a plus n minus 1d. Next thing is going to be about geometrical progression. And instead of a common difference, we have a common ratio, which is basically multiplying and multiplying and multiplying by a certain value. So the formula for it is Tn equals to a Rn minus 1. Why minus 1? Because it starts with a, then it's going to be a r. So T1 is a, T2 is ar, T3 is ar squared. So when you have if you see here, the third term has square here, so it's 3 minus 1 equals to 2. So we have to use r power n minus 1. Remember that n has to be a natural number. And everything I mentioned in here, like all the values have to be more or less than 0. They are the same. They all work the same way with the whole fraction stuff. But it's just the term that's different. Instead of using a term which is adding each other, it's going to be using a ratio. And the geometric mean is different because of this. So the geometric mean is actually b squared equals to ac. So b is equal to plus minus ac, square root of ac, where a, b, and c are in GP. And same thing with the AP stuff. So c is equal to plus minus square root AE in if A and E are given and there are 3 geometric means in the middle. And then you can just follow through, like b equals to plus minus square root of AC and so on. Or you can do the same thing with this part here, and solve it that way. And then last one is Sn equals to sum of a power r a bracket r power n minus 1 bracket over r minus 1. You can actually or a bracket 1 minus r power n over 1 minus r. So if you remember correctly, both of these can actually be used. The only difference is you might have to place more negative numbers here, but it actually doesn't matter which one you use. And the last thing you have to know is sum of infinity. If it's convergent. Convergent means that the numbers get smaller and smaller and smaller the longer the progression goes. So if you want to make it smaller and smaller and smaller, r has to be less than -1 and more than -1, but less than 1, which means it has to be 0 point something something something, either plus or minus. That means the number will get smaller and smaller and smaller. So the formula of that will be a power over 1 minus r. Because if a power 1 minus r n and r power infinity equals to 0, so hence not 0, 1. So wait, it is 0 because 1 minus 0 equals to 1. So a 1 over 1 minus r equals to a over 1 minus r. I would love to mention why r power infinity will equal to 0. It is actually quite easy to say why, but I'm not going to waste more time because I want